Today on Engineering Newswire, we're controlling a telepresence robot with our brains, simulating a virtual bleeding leg wound, and teaching robots to learn like babies. Italian and Swiss researchers are giving adults with motor disabilities more independence by combining brain control with a telepresence robot. The team uses the term shared control to describe their system, which lets the robot and user work together to achieve a goal. Using a non-invasive brainwave headset to interpret the user's thoughts, the user can tell the robot where to go by imagining the movement of hands and feet. The movements are associated with specific commands such as forward, backward, left, and right. When the software system receives the signals, it converts them into commands that the robot understands. The hardware itself is not that complex. The robot is essentially a laptop mounted on a rolling base with a webcam that lets the user see the robot's surroundings. And thanks to its 9 onboard infrared sensors, the robot is able to move around obstacles while still obeying the user's overall commands. Skype comes pre-installed on the machine so the user can talk to anyone they encounter. The researchers are hopeful the technology will provide disabled individuals with more independence in their homes.
If blood makes you queasy, it's time to look away. To better prepare combat medics for emergencies in the field, researchers from the University of California, Los Angeles have created the first detailed simulation of a human leg injured by flying shrapnel. In addition to showing how a ballistic projectile would pass through the leg, we also get to witness a hemorrhage simulation in an injured leg both standing upright and on the ground. The researchers specifically chose to simulate an injured leg due to the common occurrence of improvised explosive devices on the battlefield. Plus, the leg also has a simple geometry that is easier to model than other body parts. And it is extremely true to life. It includes bone, muscle, skin, along with a very realistic vascular system that drives the flow of blood. According to the lead researcher, Jeff Eldridge, the team is working to solve the governing equations of fluid dynamics and tissue mechanics to create truly physics-based simulations. They hope to eventually run the simulation in real time so that training medics could administer treatments such as drugs or a tourniquet and instantaneously see a realistic reaction. However, solving the necessary fluid dynamic equations would be very computationally intensive, so for now, training medics continue to study injuries to real animals.
University of Washington developmental psychologists recently collaborated with their computer scientist colleagues to teach robots how to learn like infants. You see, babies learn about the world by exploring how their bodies move in space, grabbing toys, pushing things off the table, and by watching and imitating adults, even some of our less tasteful or responsible actions. This is so much cheaper. Doesn't go with coffee. And we're out of the gin. But when roboticists want to teach a robot how to do something, they write code or physically show the robots how to perform an action. Now this team has demonstrated that robots can learn much like kids by amassing data through exploration, watching a human perform a task, and determining how to best carry out that task on its own. As to whether or not that's a good thing, I just don't know. Really, this is a possible solution for the everyday household robot consumer. If you're not a programmer, how do you get your robot to fold your clothes exactly the way you like them? With a 4, not a 3 in the pants, for creases here and here. Or do household chores appropriately, like you dust and then vacuum, or your wife scolds you. The team used research on babies to develop machine learning algorithms that allow a robot to explore how its own actions result in different outcomes. Then it uses that model to infer what a human wants it to do and complete the task or even ask for help if it's not certain how to do it. So why not design robots that can learn as effortlessly as a child? I don't know. My first thought, what if the robot winds up working in a broken home? Stop hitting the sauce.
Do you have story ideas? Comment below.
We'll cover them in the next episode.
We'll cover them in our next episode.
I'm Andy Berg.
I'm Andrew Berg.
And this has been your Engineering Newswire.
And this has been your engineering newsletter.
Nailed it!
Newswire.
Newswire. Oh, yeah.
Smells like my dad.